Hello, my name is Dave Hansen. This is my presentation for SPSM 5710 Space Communication Systems, and what we're going to be focusing on this presentation. So the contents we're going to go through with this presentation include the introduction, purpose of IRIS, history of the concept, description of the system, some test results, disadvantages of disadvantages of Iris, and changes to traditional SATCOM that need to be made in order for this to be successful. So, as the 21st century progresses, the technology used by the United States military has changed to a network battlefield in order to stay in contact with leadership and to allow the soldiers to succeed in combat. Capabilities that were only dreamed about in the past have become reality within the military and are required to ensure success. So this includes providing data from platforms such as unmanned aerial vehicles and other intelligence surveillance requirements, ISR capabilities that provide the audio and visual data to the soldiers on the ground. This technology has become vital to the commander, and unfortunately, based on the lack of terrestrial infrastructure, it is necessary to ensure that information is provided to the entities that need it most through satellite communications. So as I was saying, since that terrestrial, so one of these methods to improve the Fortunately for us, there are entities that are willing to take this unorthodox approach to finding new. So at this point, it's important to point out that while Iris is revolutionary, there is a history of IP SATCOM there's history of Internet Protocol over SATCOM in the past. So beginning in the 1970s, there was an experiment using the Transmission Control Protocol, Internet Protocol, TCP/IP experiments that were conducted to prove that this technique was possible over geostationary Earth orbit satellites. Unfortunately, what happened with this is there was a long propagation delay with the satellites to geo orbit, and along with atmospheric effects, it appeared as network congestion and link errors to TCP/IP congestion control algorithms. Unfortunately, what that did is that reduced the data rate in order for the TCP/IP algorithms to find errors and process and return to full transmission at a fairly slow rate, so although this is a DoD system, one of the things that was important about this is that the DoD worked with satellite industry to prove this concept. So what happened was the IRIS package was hosted on Intelsat 14 satellite, which is connected to two 36 megahertz Ku band transponders and one 36 megahertz C band transponder. So the hosted payload itself consisted of a satellite IP modem that is programmable, an IP router, an up converters, down converters that transition the signal between Ku and C bands, and an additional 70 megahertz. So what this hosted payload did was it provided cross-beam and cross-band connectivity, which meant Ku band users are able to communicate with Ku or C band users, just as C band users are able to communicate with C band or Ku band users. This also is a benefit because since there doesn't have to be a C to C or a Ku to Ku, you can reduce the using IRIS technology. There are benefits to the use of to improving the efficient use of satellite communications bandwidth due to the inherent ability of the data to be agnostic of the path. The best way to describe this is use an analogy of the railway with a highway. If you have if the tracks on the railway are unobstructed, I have a direct path to the intended destination. This is probably the quickest and easiest way to deliver the product. Unfortunately, with that, the method will only work until there's a blockage on the tracks and the train cannot reach the destination. In this case, the highway is more flexible because it allows for many different paths to the destination. The product is able to be delivered via a different path. basically what this comes down to is the railroad tracks act as a bent pipe delivery system. If there's an issue such as a failed piece of equipment on a satellite, the direct route of satellite communications does not allow for data delivery. Iris acts more as a highway, where it has different routes where it can deliver data, and the inherent flexibility that is included in the system increase the reliability rates, allow for confidence that vital information has a better chance of being delivered to the. So we will begin. We'll now talk about some of the test results. So IP routing space system deployed or was launched on November 23rd, 2009, with on-orbit tests being performed in 2010 to determine if the system worked as intended. As if any test of any satellite communication system, is important to test out the voice quality of the system, make sure it's working as expected. So using voice over IP, results of the test showed that there were major factors that affected the performance quality of of the system, and one of these was with the one-way delay. Additionally, when the network was hosting heavy traffic, there were higher packet loss rates, packet discard rates, and protocol packet delay variations. What was concerning about this test was the unexpected low performance. However, it was determined that the cause of this was through the traffic generator. In order to build that heavy traffic that was used for testing was causing these systems. So overall, the voice communications were considered fair and acceptable for satellite users. Another test that was used to determine performance was through the testing of video VTC capability. The VTC performance was acceptable and nearly identical between medium loading and heavy loading, with one-way time delay being the biggest detriment. Web performance was also tested throughout the testing period by browsing different web pages throughout this period. As expected, during heavy periods, web pages larger than 50 kilobits performed worse. So Iris is not immune to these issues. However, as the use of satellite communications moves away from the traditional transponded systems, there's also the need to change the thought process on how to respond to disadvantages of geosatellites. One of these processes is related to the technology involved with the components of the spacecraft. Due to the inability to install new hardware on geosatellites, satellite programs in the past have minimized the amount of what's considered high technology or very technical equipment. In order to Iris be successful in the future, it is necessary that software modems are upgradable, which is high technology, which will ensure that the efficiency of the network is always using the newest technology to provide satellite communications to the user. It is also necessary for the Iris spacecraft to be technically complex in order to accommodate the performance as required by the network. Example of this is with the routing table on the spacecraft that needs to have the scalability to process the information that's transmitted from the ground station, or the Earth, the hub, to the ground users. This includes a system that's able to increase the backbone of the system to match the growth of the internet. Essentially, the equipment on the satellite must be able to accommodate the changes to the internet to ensure that the supply of data will continue to meet the demand of the user. So there are additional challenges that are fine anytime the government's involved in a satellite communication program. The first issue is the time it takes for the government to develop the requirements, or to figure out what the requirements are versus what the development and production of the satellite is. During this time, it's common for operating conditions to change. An example of this was found when the Iris system was developed with specific waveform used for United States Central Command, otherwise known as CENTCOM. Unfortunately, the delays over a year with the Iris contract due to requirements development caused the hosted Iris system to be placed on a different satellite platform, with the Intelsat 14 ending up over South America, out of view of CENTCOM. If the test was going to be performed with CENTCOM, there would have been even longer delay due to finding a new satellite to host this system on, which is unadvisable based on timeline and cost of Intelsat and Cisco. Another unique challenge that was found was with the government, with the ITAR. While there are challenges, which is known for all GEO satellites, there is benefits that can be found through this system. One of the benefits with Iris is there is the ability to avoid the complex axis that has to be performed through performed with traditional bent pipe satellites. What this means is you can have somebody that's not necessarily taught satellite communications to be able to still receive the satellite communications. Additionally, IRIS support or provides the ability to support military personnel that are on the ground in areas where terrestrial connectivity is limited or non-existent. This technology is very beneficial to the military, but it's also beneficial to other entities, such as law enforcement agencies that respond to natural disasters or emergency situations. So, since law enforcement has to react very quickly, the IRIS system allows for quick access to the satellite, to the communications that are necessary. Additionally, with the natural disaster response, typically the terrestrial infrastructure has been either completely erased or is very limited. For example, in a situation such as a hurricane, where the terrestrial infrastructure and populated area will be non-existent or overwhelmed due to the flooding, winds, whatever it may be. But the unique nature of IRIS allows for communications to occur since it is a satellite system rather than a ground-based system. So it is easy, as a conclusion, it is easy to see in the future where the bandwidth that is used for satellite communications becomes oversaturated and unable to meet demand of the user. This means that there needs to be a change in the thought process and technology that is being used to fulfill the demands of the user. Well, traditional bent pipe systems have worked in the past. Unfortunately, there are limits on the capabilities of this technology. IRIS provides a unique ability to provide these services while also decreasing the amount of bandwidth that is used by traditional systems. It's important to point out that as with any other satellite in geostationary orbit, there are disadvantages that's found with IRIS due to the distance with time delay. Can't fix a satellite if it's broken, and it's difficult to upgrade the satellite as new technology is different or is developed. This has caused the satellite industry to avoid using complex technology on a spacecraft, even though it means the potential of the spacecraft is diminished. The developers of IRIS have realized that it's time to change that thought process and build components that can adjust to changing technology. Although IRIS is a complex system, the ability to improve this system performance has shown that IRIS is a future of satellite communications, and that the lessons learned from the system should impact the effectiveness of other systems. IRIS has shown that the future of satellite communications can improve bandwidth utilization, and the technology should continue to grow and be implemented throughout the satellite communications industry. So here's a list of the references I used for this presentation. That's all I have. Thank you for your time.